Huh?
Like we just talked all the time?
Yeah.
Hey, I'm chilling with that.
Listen, I'm gonna try to start doing more lectures when I talk to the whole class. I don't think it's gonna help the online people because judging by my YouTube analytics, nobody's watching the videos that I make. But
I'm subscribed.
well, I know, but when I look on and I see the views, it's like this video has 3 views. Average viewing time is 15 seconds. So I know that y'all aren't watching, and not that y'all need to be because y'all are here in class, but YouTube breaks it down. They let you know. Close your Chromebooks. Close your Chromebooks.
Show up to those people's houses.
Huh? No, yeah. Why aren't you watching my video? Knocking on the door. Open up. Hello.
Don't break through the window. No.
Jerry.
You better not make this video.
We're talking about my YouTube analytics and how nobody's watching these videos that I make.
What's wrong with y'all? Watch them.
Well, to be fair, all of them are in class. They get to watch it in real life as it happens.
Man, it's gonna get the live closer.
Yeah. Yeah, you're in my live studio audience. By the way, a quick side note. We watched this little, I don't know if it's a YouTube special or what, but they were talking about how, like, when my generation was growing up, all these shows had the laugh track. They had the live studio audience.
They're all dead.
And when they do it, they do like a joke, the audience would laugh. And you hear like, ah, ha, 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 ha. And now shows have gotten away from that. And like all the shows that like have happened recently, like, well, these aren't too recent, but like Full House is one of the laugh track ones. But Big Bang Theory is actually one of the ones that still has it.
Yep.
But like The Office and all the new like really good shows don't have it. And when you watch a couple shows that don't have it at all, and then you go back and watch one that does, you're like, this is really weird. Like they all stop talking and you let the audience like laugh for a little bit and then they go back into their normal thing.
Telling you when to laugh.
Yes, and that's what they talked about, how it was kind of like it kind of got invented in the era before there was really a lot of comedy TV, and to help people like get into the comedy mood, they would have people laugh, and it lets you, oh, this is funny, I should be laughing here. That's actually a pretty good joke. It's just real weird. Yeah. We're not going to talk about that today. But
Places not knowing it's comedies and just sit there.
no, I don't think it's like that. I don't think it's like that, but
They should have crying tracks to let you know whenever it's a sad scene.
yeah. Well, in the laugh track ones they do, because in a lot of comedies they'll have like a couple.
Like, oh.
Yeah, and I remember that being a big deal because like this is probably before y'all's time, but like the Fresh Prince of Bel Air, when Uncle Phil died, like that was like a big deal.
Wait, Phil dies?
I think so in the show.
I didn't finish it.
Oh, my bad. Spoiler alert. Yeah, my bad. But yeah, when he dies, like the whole audience is just like gasps and sad noises, and yeah, it's pretty crazy. But anyways, listen, we're not talking about that. Today we're going to talk about how science tells you when to laugh and when to cry about the universe being created. Not really. I don't know. I was trying to make a segue there. It didn't work out. Yeah. Laugh. Everybody laugh for the people at home. So listen. All right, let's refocus. Hey, let's refocus. So what we're talking about today is the Big Bang Theory. What it is, we've talked about it a little bit here in class. We're going to go into details about what it is, how it was discovered, why we're kind of on board with this, and what this means for us and the universe and how we study it. So they start off with this chapter, and when we start doing the assignments, I'm going to assign the reading. Y'all have all been through Cecil's class, and so for whatever reason, I have a hard time like teaching from Discovery Education. But I know that y'all know how to go through and use Discovery Education a little bit. I do think that biology is probably a little bit better than the Earth and space stuff. But know that you shouldn't just be pulling up the multiple choice assignments and just guessing. You can go through and find the questions. You don't have to read the whole thing, but you can go through and find some of these answers and try to get a little bit better understanding of the question before you submit it. But hey, I don't need a laugh track on the side. We're going without the laugh track here, without the comments. So both of y'all, well, turn around and don't face him, and then engage with him.
Engage.
Don't engage. All right. So the Big Bang Theory, basically less than a century ago, the universe was thought to be static and infinite. Like it's always been here. It's always been the same. It's just an infinite, as far as back as you could ever go, it was the universe. And you could even go to like religious ideas of creationism, that God created the universe just as it is, like he brought it into creation. Which again, science isn't like trying to disprove any of that. And I would even argue, if you want to look for a marriage point between religion and science, the Big Bang Theory, in a way, is the most scientific way to point at creation. It was this instantaneous creation of everything that we know, that science cannot prove, or cannot even really like establish what triggered it. Like we talk about the Big Bang Theory, when you get into like why did it happen? What was it before the Big Bang happened, and why did it suddenly just explode into this huge eruption? There is no real scientific evidence for anything to point to that. And so I think, and I think I've talked to people who very much look at creationism in the Big Bang Theory. And so just remember that science is not out to like disprove religion or anything. And I know that every year that I teach about this, there's someone who kind of disagrees with this, and it gets a little bit controversial. But there's a lot of evidence to support this, and it's not necessarily one versus the other, or take it or leave it. You can kind of have both in certain areas of science. So less than a century ago, the universe was thought to be static and infinite. This was called the steady state theory. Basically, that when you look out into the stars, they've always been like that. They always were like that. This is what they are. This is what the universe is. And so in the 1920s, an American astronomer named Edwin Hubble, did we name something after him because he figured some stuff out? Yeah, the Hubble telescope. It's literally like the most famous telescope in human history. Maybe outside of the telescope that Galileo built. But everyone today knows about the Hubble telescope. And I watched an interesting YouTube video. This guy, Scott Manley, it's like this British dude that talks about space. He was basically making an argument that in the future, a company like SpaceX or maybe some other private company should go out, because it's going to be obsolete soon. They should go out and catch the Hubble telescope and bring it safely back to Earth to put like in a museum, where people can go and actually physically see the Hubble telescope, because that's something you don't get. Once you put something in space, you'll never be able to see it again. Like we can see pictures of it before it left, but you don't get any interaction. Like school children, high school students don't get an idea of the size and the complexity of this thing that we send up into space. It's not that big. I think we looked it up in maybe last week, and it was like a couple, because I said like 9 meters and it wasn't 9 meters. It was a little bit smaller than that. No, because 9 meters is pretty big. But yeah, it wasn't not, it's not the size of this room, but it's pretty large. Yeah. So I'll look it up in a little bit if it doesn't say it. But Edwin Hubble, before the Hubble telescope, Edwin Hubble discovered that the universe was in fact expanding. And we'll talk about what he saw when he saw that it was expanding.
How much is the Hubble telescope worth?
I mean, how much? We'll look it up when we look up the size. I'll look up how much they spent on it. Now, worth. I mean, you can probably say priceless right now, but how much did they spend on it? That'll be on the Wikipedia page. So this showed the steady state theory to be invalid, that everything isn't just as it was and always has been, but it's moving and it's expanding. The Big Bang Theory eventually took its place as the generally accepted theory explaining the origin of the universe. So what is the Big Bang Theory and what does it say? And I've got this highlighted from a previous year. The Big Bang Theory states that the universe formed during a single event in which all matter and energy suddenly expanded from an extremely small point. Notice they don't say like how big it is. Some people say it's just like a point in space and it doesn't really have size. I would think it's going to be something similar to like a black hole. Maybe not super large, but who knows? It could be like the size of a bowling ball. It could be the size of maybe a small planet or a small moon. or it could be much, much smaller than I think. When you get into physics and compression of matter, especially like in a black hole, things get really weird.
Are we talking about like solar system? Are we talking about space?
Everything, literally everything that we can see.
So what was outside of that? What was outside of that
So
black
when
hole?
you get into that, basically, now this gets into Einstein stuff, but
Turtles.
there's really nothing. No, because basically, when you have something like, let's say this is a black hole, and this is going to be weird, and I don't know that I can draw this correctly on the board. When you get near something like a black hole, I don't know how to do this. Space and time get bent; they get altered. And this kind of gets touched on in what's the movie we talk about all the time? Interstellar, where he goes near the black hole and time passes differently for him than it does for the people back on Earth. So by the time he gets back, he hasn't aged very much, but his daughter's like middle aged, where when he left, she was like 10 or something.
His daughter's
She's like
90 and 8. Yeah.
All right, at the end of the movie, yeah. Well,
it's like he comes back and he's like, "You'll name a company after me." He's
Yeah.
like, Your daughter.
And so yeah, she's like old age by the time he gets back. But that's like this bending of space time. And there's people who try to visualize it. It doesn't. If you don't fully like grasp it, which I don't even, it doesn't make sense. But if you have something like a universe encompassing Big Bang type black hole, where you have a point that literally has everything inside of it, space and time would be bent so much around that there's literally no space and no time outside of that black hole.
So if you're going by that, he's like never age.
But you couldn't even really exist because there's no space for you to be outside of that because there's no space. Everything exists in that one point. And basically it's hard to fully comprehend, but there's some math to support this, and it is basically a theory. But one of the things about black holes and about this singularity that has everything inside of it, it kind of erases all data. There's no light, there's no stars from that point. There's no energy that was outside of that little ball. So there's nothing for us to look at and be like, oh, this was going on then. It just kind of is what it is. Now, maybe one day we kind of alter this theory a little bit and we understand a little bit more about it. But yeah, the answer to that, what would be outside of that, is nothing. No space, no time. Nothing could exist outside of a singularity like that. Or at least that's what we understand. Which, when I get into the big crunch, poses a problem for humanity if we want to like live on forever. Not just as individuals, but as a species. There gets to be problems with that very, very far in the future, which we may not even make it to. Yeah, this point is called a singularity. It is thought to have been infinitely small, which I still have trouble like understanding in my brain how all the matter can be even smaller than like a giant black hole. Just a super amount of gravity pulling everything down into a super small point. Infinitely dense and infinitely hot. So just things that we can't even really fully wrap our brain around. It is thought to have been smaller than a single atom and made of pure energy. One of the biggest mysteries of the universe is how the entire universe inflated at an extremely high rate from a point smaller than a single atom to the size of a baseball almost instantaneously. And this is where we get things get a little bit weird. Keep your head up. I know this might be boring, but hey. We say that nothing can travel faster than the speed of light, right? Well, when you get into the Big Bang Theory, space itself traveled faster than the speed of light. But empty space is essentially nothing, right? It's not matter. It's just it's an allowance for time, an allowance for space to be there. That expanded at a rate faster than what we consider the speed of light. And so, instantaneously from a very small point to maybe like the size of a baseball. But even after that, it continued to expand extremely, extremely fast, faster than the speed of light. So when you get into like particle physics and astrophysics to the extreme, it becomes a weird point where people are looking for ways to kind of like break the speed limit of light with spaceships and stuff by using gravity to kind of bend the space-time continuum. It gets really weird. But basically, when you get back to things like the Big Bang, there's still a lot that we don't understand. We're attempting to explain stuff. We know that we're probably pretty close to right with the Big Bang because we have lots of evidence for that. But what happened in those first few seconds? What happened, before the Big Bang? We can only guess at. I don't know that we'll ever have any hard evidence to kind of support our ideas about that. To measure the age of the universe, scientists use units called light years. We've talked about light years. It measures the distance in space equal to the distance that light travels in 1 year. 1 light year equals about 9.46 times 10 to the 12 kilometers, which is a really big number. Let's just write that out. 9.46 times 10 to the 12, so that would have 10 zeros after it. Kilometers.
7 zeros.
Huh?
Just for context. A million has 7 zeros. Just for
Yeah. We can put these in here. So 1,000, million, billion, 1,000, million, billion, trillion. 9,460,000,000,000 kilometers per year. Per year. It's a light year, yeah. We've already talked about electromagnetic radiation a little bit. So just remember that light travels at that speed. And so when we get light here on Earth, if you're looking at something very far away, or even something just a little bit far away, you're looking into the past. You're only seeing that when that light left, which was maybe thousands of years ago, maybe hundreds of millions of years ago, and that star may not even be there again today. Yeah. A lot of the stuff that we see, based on the size and where we guess that it is in its lifespan, it's probably already gone. By the time the light gets here, it's gone. And that's another problem with us maybe even talking to aliens. If there are some other beings out there in the universe and we get a radio signal from them, if they're like, even if they're like 100, like let's say they're just 1 million light years away, by the time the radio signal gets here and we send one back, it's been 2 million years before it gets back to them since when they sent it. They may not even be around. They might be dead. There could have been something that happened. Their planet could have been destroyed. You never know.
So, will we ever see like the end of the star, like in space, like looking up at the sky? Will we ever see a star explode?
I believe we have. I don't know about recently with good telescopes. We've seen just afterwards, the gas cloud from a supernova. I don't know that we've actually watched one go off. I think we have a couple likely candidates, but the problem is there's so many stars, and even if you include like the whole Earth, we only have a handful of telescopes that can realistically look at this with detail. I don't know that we've like fully seen one like in the instant it goes off. Now, historically, humans have, and we've gone back in old records, and I think I talked about this before. We've seen a part of the sky that has the gas cloud from a supernova, and then historians will go back and be like, oh, this guy wrote about seeing a bright light in the sky for like 2 weeks straight. And then they piece it together and like, this guy saw a star go supernova, and the sky like lit up with its explosion.
How far away does the star have to be for us to like still feel the shockwave with it?
It'd have to be extremely close, but they do theorize that there are some stars in the history of Earth that we have gotten actual physical effects from when they've gone supernova. Not like Earth destroying or anything,
Right.
but like increased light, increased heat. I don't know about like a shockwave or anything because there's not really. There's not air, so it's not going to be like a normal shockwave, like an explosion here on Earth. you'd really only get electromagnetic radiation. Probably not even matter.
Like you wouldn't like. Do you like see like the stuff expand from the star, or would it just like?
I don't know if there'd be anything that close where we could see it. Basically, from here, we would just see it get a lot brighter for a while. And some of them could be as bright as like the sun, where you don't have nighttime, but for like 2 weeks, it just looks like daytime outside. Yeah, it is. It is pretty crazy. So basically, Hubble sees the expansion. We go to our scientific work over here, and we're like, all right, so here we are. Everything's expanding away from us, or expanding away from this central point, and we can get a speed of these things, and we just basically put it in the computer and play it backwards, where you do some math and you run it backwards, and you say if it's going this speed heading away from us, we put it in reverse at that speed, and it goes back towards this central point.
So we can
How
figure
long
out
would it
where
take
it's
it to
going.
get back towards this central point? And that is how we get the age of the universe as we know it, which we're estimating right now to be 13.7 billion years. And this does change. I think just last year, someone theorized that expansion rate is happening a little bit faster than we thought it was, and they shaved like a couple 100 million years off of the age of the universe. I don't know if everybody accepted it, but that's what they were basically writing for. So it's hard to kind of get this overall, everything's moving at the same speed, how old is the universe? But the consensus is that it all goes back to one single point. So we've talked about the Doppler effect in chemistry. I think I did in this class where I ran back and forth and was like, meow, meow.
I don't remember.
Yeah.
Can you say it again?
Yeah, I don't
No,
remember.
you're fine. You're fine.
That really would be a giant explosion and still be pushing stuff out after blowing up.
Yes, but remember in space,
Years ago.
there's no resistance. And so once you send something on its way, it's just going to keep going. Now, when we get back to the end results, there is still more gravity in the center around where that happened than there is towards the outside. And so the question is gravity going to stop everything and pull it back in the same way where if we just shot a rocket up and it wasn't going like around in orbit, it didn't really matter how far it would get. Even if you got past the moon, it would eventually get pulled back down into Earth's gravity and come back. Or are we going fast enough, like some of our spaceships that we send out, it would just keep going forever. Those are the two different ends of ultimately what the universe is going to do. But the Doppler effect is what Hubble used. He determined, he used this principle that if something's heading away from you, the waves that it put off are going to be stretched out further. And if you're talking about light, that's going to give you a red effect. If things are moving closer to you, the waves are going to be compressed, and you're going to see them like they're coming faster. And so that's going to be more blue light that you see. And so basically, they kind of explain that here. Redshift happens when a luminous object is moving away from the Earth. Blue shift is the apparent shift of light wavelengths towards the blue end of the spectrum, meaning that it's happening when things are heading towards the Earth. And when we look out at almost all of the galaxies in the universe, not every single one, but the vast, vast majority of them, they all appear more red than they're supposed to. For their size, the types of stars that are burning, the average size and color of stars, most of the galaxies appear more red, which told Hubble that they're all heading away from us. And as controversial as this theory is, lots and lots of people would love to be the person that disproves this. But when you get your own telescope and you start to look at these things and you understand the math, it really works out that when you look at these galaxies, they are heading away from us. They are kind of making the point that everything is expanding. And if everything's expanding and getting bigger, then you can guess that without some sort of action to kind of make them slow down or make them speed up, they all came from the same point, from the same area. And so we can trace them back and kind of calculate where the center of the galaxy was and where the Big Bang kind of happened at. So I don't think that. I think that's an assignment there. So some more evidence for the Big Bang. Hydrogen and helium are the most common elements in the universe. In fact, hydrogen and helium may compose more than 98% of all the matter in the universe, unless you're talking about dark matter, which things might get a little bit different. The next most common element in the universe is lithium, which, if you look at the periodic table, lithium is literally number 3. Next step up from hydrogen and helium. Hydrogen has 1 proton, helium has 2, lithium has 3. And so what the Big Bang Theory proposes was that right when the Big Bang happened, there were really only hydrogen and helium atoms. And those were what formed the first stars. And it wasn't until your first stars went through their first life cycle that you actually got any other elements besides hydrogen and helium. Lithium would have been the next one, and then they just keep building and getting bigger and bigger there. And when we look out, we're not the greatest at spotting planets yet, but we don't find any planets that are anywhere close to the age of the universe. All the planets are much, much younger because, fitting with the Big Bang Theory, the first set of stars would have to go through their entire life cycle before they could even make elements that would form a different planet. It would just be stars at that point, early on.
So years from now, there's going to be new elements.
Not necessarily, because there's a limit to the elements that can be made inside a star. And so we talked about that last week too, that iron is the largest thing that can happen inside the core of a star. And all the other elements beyond that have to be made in a supernova. And when you get to the really, really big elements, they're radioactive and don't last for very long. So they all decay down into something like lead or iron. Not iron, but lead is usually a common one. So the fact that most matter in the universe consists of these 3 simplest elements is therefore further evidence for the Big Bang Theory as we understand it today. They talk about that. I just talked about that. They say the Milky Way galaxy is thought to be one of the oldest galaxies in the universe, about 13 billion years old, which is nice. And I've kind of made that argument to y'all that, we could be, as far as life, if life forms on other planets, and if we end up finding other life in different parts of the universe, we could be one of the oldest ones. As far as the time frame that it takes for galaxies and planets to form, we are probably early on in that evolution, if you will. And even life here on Earth didn't take too long to form. We could be, if there are other life forms and if we find other intelligent things, we could be the old ones. It would be difficult to find other life forms that have been around for like billions of years before us.
Okay. If space is so big and vast and we have no idea how far away, like the edge, well, there is no edge because it's like.
There's an edge to what we can see. Now, if we start to travel out, maybe we change where the edge is. Right. Kind of in the same way early explorers thought that the Earth ended right here, and then they got there and they're like, oh, it keeps going around.
Right.
Yeah.
So if it's so vast and everything, why do scientists keep trying to understand and say oh, if there is life, it's probably not as smart as us, whenever space is so big you can't say what there is.
That's part of the human condition. And most good scientists will not say, that there's not intelligent stuff or that there's not life. They just say we haven't found evidence of any of that. But yeah, it's part of the human condition that we like to feel superior. Even there's animals on this planet right now who do things that are extremely intelligent. And yet we consider ourselves the only intelligent beings. But you see other animals make decision-making processes, and there's birds that use tools and monkeys that use tools. And maybe we're more advanced than them, and maybe our language and our opposable thumbs help us out a little bit. But the idea that we're the only intelligent things when, not that they have language, but we can't even talk to anything else on our planet. I don't know. That being said, we've taught gorillas how to speak, sign language and stuff. And one of the things, I don't know how accurate this is, but one of the things I heard They would never ask a question. You could ask them things and they would answer. They would talk about their feelings. They would do stuff, but they would never be like, what do you do when you leave this room? Do you have kids? Are you happy? I don't know that they got to that. And that could just be that it was just brand new to that one gorilla, and it hadn't been like a learned skill through many generations. I don't know. It's interesting. I saw a YouTube video. A lady taught a cat to follow like physical commands and do things. And that was the first time anyone's taught a cat to do that. We just thought that cats were like dumb or mean. Hey, cats are nice. I have 2 cats and they're wonderful.
I have 1 cat. I'm gonna throw it outside.
Well, he probably knows that, or she probably knows that, and she's plotting your doom.
Good. I'm just not gonna do that.
Hey, don't be cruel to animals. That's the beginning of becoming a serial killer.
Gage's been on that path for long.
Well, you got to be a good friend and help him out a little bit.
I'm just letting it go.
Just
Good.
don't be hateful towards cats.
Are you saying what everyone's thinking?
No, let's not be angry towards animals. I'm gonna have to report y'all to the FBI. Like, y'all need to keep an eye on these people. They're taking steps towards John Wayne Gacy. So listen, I think we're getting towards the end here. Origins of the universe, Big Bang Theory. Our solar system, obviously much younger than the Milky Way as a whole. They're estimating the Milky Way at 13 billion. The universe is 13.7 billion. The Milky Way is 13 billion. Our solar system is younger at 4.6 billion years. Let's see. Yeah, and note, they're not saying, hey, this is it. This is the end all be all. We're right. We're perfect. We're still working on this, and this theory is still being developed. Like I said, just the other year, they changed the expansion rate, which changed the overall thought of what the universe's age is. And then they talk a little bit about what happened following the Big Bang, the expansion of the universe. Let's see, how much time do we have left?
Like
3
2
minutes.
Oh my god. Oh, just like
13.
3
Let me
minutes.
just check my watch.
13 minutes. Let's watch
Oh yeah, video.
let's watch a little bit.
time. Is it Interstellar?
No.
Can we watch Interstellar
Let's see this one.
sometime this year?
Introduction to
I don't know, maybe if Mr. Bailey takes if I take a couple maintenance days to just like clear my head, maybe.
You should do that.
I'll teach.
I think Mr. Gallagher showed it, and I don't think there's any like too bad cuss words, so maybe we will watch
It
that.
really is also teaching.
Huh? Yeah, you can go blue rooms. But I'm gonna play the video. We're not gonna wait for it. All right. Oh, that's loud. We got the rumble.
This is our world.
Oh, maybe I shouldn't let the video see this. I don't want to get demonetized.
Forests. Oceans.
Well, this is on
And people.
Earth and on Discovery Education.
Everything in the
Let's be able to
universe
see
is
this.
made from matter.
So just to point out, the machine they're talking about is a particle accelerator or a collider. We could have had that here, literally right here in Ellis County, and we started to build it, and then we canceled it.
What? We could have been the Flash.
We
What?
maybe you might if you've gotten trapped in there, or it could have just been like a raccoon, and you could have had a flash raccoon. I don't know. But let's finish the video.
As well as space telescopes to peer deep into our past.
We are getting close to answering the old age questions. Why are we here? Where did we come from? Does the universe, in fact, have a beginning or an end? And if so, what are they like? If we find the answer to that, it would be the ultimate triumph of human reason. We would know the mind of God.
I wish it was longer. That was Stephen Hawking. Stephen Hawking's like one of the most famous physicists
How
ever.
smart is he?
He did pass away last year or the year before. Extremely smart. The guy is just crazy. And part of it, I'm sure he'd even agree with this, is part of his physical limitations. his disease took his ability to move at a relatively young age, and it actually happened before he had the ability to have like the speaking machine that he uses, and so for several years he was essentially just trapped inside his own body. He could think, but he couldn't speak or talk to anybody or communicate. And yeah, I'm sure it was not a fun place to be. But to kind of cope with that, he thought about what he enjoyed, which is what he studied before, is the universe, the creation of the universe, what's going on. And so when he finally got the ability to speak and to communicate and to write his own papers again, he obviously had some ideas that other people hadn't really thought of. And so yeah, he was extremely smart. So they talk a little bit about what happens after the Big Bang, an expansion of the Big Bang, and maybe we'll talk a little bit about that tomorrow. I wish they had the rest of that universe. Maybe this one. I mean, we're not going to watch this today, but I want to see what.
Isn't that the one we just?
No, this is a little bit different.
Give or take a couple of planck times, the universe is nearly a second old, and still a very strange place. But matter has won the battle with antimatter. And now it's time to build the universe. It's still extremely hot and expanding incredibly fast.
When the universe was second old, the particles in it were very different than the particles we see today. There were no atoms. Nothing that we recognize in the room around us today yet existed.
However, now all that begins to change. Temperatures continue to cool, and as the primitive particles keep slowing down, they start bonding together to form the atoms of the first elements. The first one to form is hydrogen.
And this is kind of where we get to this understanding is using particle accelerators. We take these atoms, we smash them together, and we find out there's more stuff in there than electrons and protons and neutrons. There's weird subatomic particles like leptons and quarks and all sorts of. There's what is the name of the other particle that they search for forever? The Higgs boson. There's all sorts of weird particles that exist in these atoms and make up the atoms that we've never really seen before, and you can only create by kind of destroying them. And so if you destroy them and get them to come out by themselves, then they might have been the things that existed before all of this energy kind of coalesced into matter, and we got our first atoms like hydrogen and helium. And so, you know, these particle colliders, like the one in CERN or the one they started to build here, have kind of opened up that idea.
Is it still like there, or do they just like tear it?
Yeah, no, it's still there. And I mean, y'all have the Super Collider Road that y'all call. I don't know if that's the name of it, but
Campus Road at the very end of it.
yeah. That was, I think that was built as part of this, and there was going to be like an outlet to the tunnel. And I probably don't have time, but you can pull up a map to show you where the Super Collider was going to go. Let's see.
Why didn't they make it?
Funding fell out. It was basically we weren't going to give a whole bunch of money to. I want a better one. No, we just weren't going to give a whole bunch of money to science because you know it's all tax money and you got to convince people. It was basically that or the International Space Station, and they chose to go with the International Space Station. So here's Hatchie. It goes way down here, probably near what is this? Italy. Down there, 35 comes back around. This is that Bardwell?
Yeah, it was Bardwell.
That's Bardwell. So where's Innes is gonna be? Like down here, maybe?
Oh no, it's like on the edge. Look at Bardwell and then go a little up. It's like around there.
Oh, Innes is up here. All right. So Bardwell's like right by Innes. Okay. And And then you come up here, and this is probably 878. So this is probably near Palmer, right here. And then it come back up. I think that might be Rocket. Yeah, and so that's it. And they actually had most of this built. They had the vast majority of it built. Here's the tunnel. So this is it coming up. This is probably under Waxahachie.
So they did all that and then just quit.
Yeah, and it actually cost them quite a bit of money just to stop it and not actually finish it. The buildings, the scientific research buildings were there. It's like occupied by like I think it's a paint company now or something. But my parents actually live out near this building. Yeah.
$2 billion.
Raise your hand,
Yeah.
Tremaine. Is there like an entrance to it that like we could go to and like go in there?
I think so, but I don't know. I saw a news story at some point in time that a guy was growing mushrooms down there. Not those just like edible mushrooms. But I also heard that it was flooded, basically, because you can't just leave like a hole like this open. It's gonna collapse at some point, and somebody's house is gonna fall through it. So I think they flooded it with water to keep it from collapsing or something.
If the farm was to explode, how big of an explosion would it make?
Well, that's another reason that kind of maybe led to us stopping it, is the idea that there would be an explosion. You're just like colliding atoms, so it's not going to be any kind of explosion or anything. To be fair, part of it is science. The scientists like frankness, because they were like, well, what's going to happen when we turn this on? And they're like, we don't know. We've never done it before. And so they're like, could it explode and destroy the world or create a black hole inside the earth? And they're like, I don't think so, but we've never done it before. So as a scientist, I'm not going to tell you with 100% certainty that's not going to happen. And so people were a little bit worried about it. All right, so I don't know that we'll talk about much tomorrow. We'll do an assignment on this tomorrow, and we'll finish out this chapter this week. Thanks for tuning in, YouTube people. Please click like and subscribe, but don't really do that. I'm not asking you to do that as a student. And watch more than 15 seconds of the video. It'll be nice.